In this video, we're doing Calc AB problem set 119. The problems in a playlist are in the description below. Let's see what we got. The function g of x is differentiable with values shown in the table above. If h of x is the integral from -4 to x of g of t dt, what is the minimum number of critical points that h of x must have? All right, so we're going to need to know what h prime is to be able to answer this, right? Because a critical point is a point in the domain at which the derivative is 0 or undefined. So let's find h prime. So h prime, second fundamental theorem, upper bound, plug it in, and then times the derivative of the upper bound, so g of x times 1. Now g of x is differentiable, which means that g of x is continuous, and that means that h prime exists everywhere, so h of x is differentiable as well. I'm not going to actually use that fact, I just thought I should bring it up here. So let's see. So we need to establish that g of x is continuous. It's not actually given, so I'm going to say that g of x is differentiable, which implies g of x is continuous. Now I'm going to use the intermediate value theorem to find zeros of g of x. So if you look at the table, you got one there, you got one there, and you got one there. So we're looking for just sign changes in the y values. So I'm going to write down those intervals. So I have g of 1 is less than 0 is less than g of 3. G of 7 is less than 0 is less than g of 4, and g of 7 is less than 0 is less than g of 12. So the intermediate value theorem guarantees that g of x, which is h prime, equals 0 at least once on each of those intervals. So let's write that. So by IVT, g of x equals 0 for some x on 1 to 3, 4 to 7, and 7 to, that should say 12, not 1. That's weird. So once we've established that, we can definitely say that h prime of x, which is g of x, equals 0 at least 3 times, and so that means that h of x has at least 3 critical points. So there's at least 3 critical points. I'm just going to jump to that. So that's how I would answer that question. It's kind of an interesting question. It's a little bit different. So I don't know. Let's do the next one. Calculator question. Find the average value of f of x, which is x squared cosine of 3x on the interval from 3 to 4. So average value is just integral divided by interval. So I'm going to write that down. F of x dx over 4 minus 3. It's a calculator problem, so I just grabbed a calculator and punched it in. And then I'll say approximately negative 2.670. I always go 3 decimals, even if the last one is a 0. I like to be able to visually check that everything is at minimum as long as it should be. All right, next up. Given that the acceleration of a particle moving along the x-axis is given by a of t equals 5 e to the t minus t squared, and v of 0 equals 4. So that's what we're given. Calculate the average velocity of the particle on 0 to 3. Okay, so average velocity is asking for the average value of velocity. To find the average value of velocity, I'm going to need to know the velocity function. So step 1 is going to be to find that. So I'm just going to integrate this thing. The antiderivative of 5e to the t is 5e to the t, and then reverse the power rule for t squared, so minus 1/3 t cubed. Don't forget a plus c. How do we solve for c? Well, v of 0 is 4, so 4 is equal to 5e to the 0 is 1, 0 cubed is 0, so we get 4 equals 5 plus c. c is negative 1. All right, so now we know the velocity function is 5e to the t minus 1/3 t cubed minus 1. Average value is integral over interval. So let's set that up. So 0 to 3 of our velocity function. So this had like an extra little problem in it where you had to find the velocity function. I actually, when I made this, when I started my solutions the first time, forgot that. And I did basically average acceleration. I was like, why is there this extra information about v of 0? And then, all right, so let's do this. It'll be 1/3. We got to integrate again. So 5e to the t goes to 5e to the t. Then you get negative 1/3 times 1/4 is negative 1/12 t to the 4th minus t. We are going from 0 to 3. So that'll be 1/3. When you plug in 3, you get 5e cubed minus, you get 81 over 12, but that reduces to 27 over 4, and then minus 3. When you plug in 0, the whole thing does not zero out because e to the 0 is 1, so we just get 5. And then if we combine these, we get 1/3 quantity 5e cubed minus 59 over 4. Kind of an ugly answer, but nothing we can do about it. All right, let's look at the last question in this set. The average value of a function f of x on 1 to 7 is 4. Find the value of, you can see that I edited this so that we could actually do it, of the integral from 1 to 7 of 3 f of x minus 4. Okay, so we want to, so we know the average value, so let's start with that. Average value is integral over interval. So this over 7 minus 1 should be equal to 4. So 7 minus 1 is 6. So we know that the integral is 6 times 4, or 24. So we know the integral from 1 to 7. I'm going to take the integral that we're trying to find, and I'm going to break it up using a lot of properties of integrals, right? So there's the integral of a sum or difference is the sum or difference of the integrals, and a constant multiple can be factored out, which gives me 3 times the integral from 1 to 7 of f of x, and then minus the integral from 1 to 7 of 4 dx. So for the first one, we know that the integral from 1 to 7 is just 24. We just calculated that. For the second one, I just think of it as a rectangle that has a height of 4 and a base of 6, or you can actually integrate it in fundamental theorem. It doesn't really matter. You'll get the same answer either way. So this is 3 times 24 minus 24, which is 2 times 24, which is 48. I like that puzzle. It's kind of like problem, rather. It's kind of like a puzzle is what I wanted to say. All right, that's the whole problem set. I hope this was helpful, and good luck.